Right, in this video, I'm going to show you how to draw a grid right onto a Google Earth satellite image. This is very helpful. Doing grids, collecting data as grids are very helpful under a number of circumstances. Number one is it gives you an overview of the layout of the site, so you can choose where you want to put your grid with some sort of reference. Number two is the best data come from systematic data collection, especially if you're looking to create a 3D visualization after the survey. Then conducting a grid is by far going to give you the most robust data, best looking data that you can possibly get. And it's because it's standardized. It's because it's systematic. And every single profile that you take has reference to every other profile. So in DX Vision software, for example, if you want to create 3D time slice views, collecting grids is going to give you the best opportunity to do that. Now, you need to collect a grid with a high enough resolution for the 3D data to overlap. And generally, you're looking at 1 to 2 feet, right? Every 1 to 2 feet, you'll have to collect another profile. In addition, you want to go in 2 different directions so you don't alienate buried services like pipes and utilities. If you go in one direction, you run the risk of completely missing a buried pipe or utility. So going in 2 directions is ideal. So how do you do this? First thing you got to do is you're going to have to bring up Google Earth. So you have to be connected to Wi-Fi in order to do this. I'm already connected. Obviously, you can see down here. Right, if I click on it, I'm connected. Okay, go ahead and get out of that. But you have to be connected to Wi-Fi, and that could be your phone. So you can connect through your phone, through a hotspot, in order to pull up Google Earth. Now, to create the grid with Google Earth, you need to click on this little arrow, and it's going to bring open a layers menu. In this layers menu, you can pull up Google Earth. You can pull up pre-done CAD files, shape files. You can pull up georeferenced maps and things like that, raster data sets. It's up to you. But generally, if you're in the field, you're probably working with a Google, something like Google Earth is going to give you a nice visualization. So I pull up Google Earth. I'm going to use Google Satellite. I found that that's been the best to use, but there are a variety of different options. And it's going to take a second to buffer. And down here in this bottom left corner, you can see where it's buffering. So we'll give it a moment. Just bring up a very general location for me. I'm not tied into a GPS, but if you're tied into a good GPS, it'll pinpoint it. Or when you pull this up, it may give you the option to tell it the address. And that's possible. So we'll go ahead and we'll zoom in and pick a random example, a random spot, okay, that we can go ahead and pretend like we're going to conduct a survey. Give it a moment. Let it buffer. All right. So here's a football stadium. We'll go ahead and we'll zoom right in to the football stadium. And let's say that we need to locate at the football stadium any services running into this, building over here. And we want to use a grid in order to do that. To draw the grid, the first thing you're going to have to do is click on the draw button. Okay, so it's a polyline is what they call it, right? So click from the arrow to the draw button or the polyline button. And then when you touch your pen, your stylus, to the tablet, it's going to give you a reference point. That reference point is going to be your 0, 0. So let's say we need to locate everything coming in to this building over here, right in front of it, in this area. Well, to get a reference point, we'll go ahead and we'll just click, let's say we have to go from here, let's say to here. It brings up that baseline. Once it brings up that baseline, you can push draw grid. Okay, now it's going to make it very large because you can see my length is pretty wacky over here. But we do that. Actually, it did it pretty well. Right? So it drew exactly what we want right here. So we have a 30 meter by 108 meter grid. Right? We drew it right on our Google Earth image. And now it's every 2 feet. So let's say that we want to go every 3 feet. Okay, it'll open that up, right? So now it's opened up. Let's say that, we kind of overdid on our length. We can go ahead and pare that back if we feel like. Okay, so maybe it's 105 feet, right? So now we have a 30 meter grid by 105, and let's say that is the area we want to cover. It's giving us our 0, 0 reference point, and that's where we would begin our survey. So if we click through to Start Survey, which is the button on the bottom, it's going to put us into the data collection mode, and it'll bring this exact visualization up. It'll start us at 0, 0, and it'll tell us which line we have to do first. And then after you complete that first line, it'll tell us second line, third line, fourth line, fifth line, and so on. After we go all the way down, right, so we collect over and over and over and over again, it'll take us back to 0, 0. We will turn 90 degrees and collect in this perpendicular direction. Collecting in those directions is going to give us the best overlap of our data, make sure we don't alienate anything. And what's an acceptable step number in order to make sure that our data will overlap in DX Vision software? If you want to produce 3D images, you're going to have to do it at every foot or every 2 feet. Okay, every foot or every 2 feet will be sufficient. 2 feet should give you an overlap. It's going to tell you exactly how many scans you have to do. Right, so how many scans do we need to do? We're going to have to do 70. Why? Because every 2 feet at 105 is going to be, approximately 53, and then we have to do, another 31 or so over here. So it's maybe my math is off, but nonetheless, that's what it's doing. That's how it's calculating it. So you go all these directions at once, and then you come back, you flip it, and you go the opposite, the perpendicular direction. This is how you draw it right on to Google Earth. Another benefit of this is if you do draw a grid and it's right on Google Earth and you interpret in real time, it'll build those interpretations right onto this Google Earth image, which will help facilitate workflow on the back end.